Hello, this is G. Om Kedareshwar Kiran from Electrical Department of 5th SEM. Today I am presenting about effect of freewheeling diode in control rectifiers and what are the control rectifiers, diode, and the what is freewheeling diode and effect of freewheeling diode. We discuss in the further slides. Effect of freewheeling diode in control rectifier. On the right side we can see the diagram of freewheel and how the AC supply is given through the transformer and the SCR silicon control rectifier, which helps the freewheeling diode for the forward bias, and how the mutually induced EMF through the transformer mutual inductance. We can see the diagram on the right side. Now coming into the topic, effect of freewheeling diode in control rectifier. This presentation is about the critical role of freewheeling diode in control rectifiers. So particularly when dealing with the inductive loads means lagging loads all come under the inductive loads. We will explore how the essential component manages voltage spikes. What are the voltage spikes? The voltage spikes means in the short period of intensity time, how the voltage fluctuates in its gaps and ensuring the current continuity and significant enhance of performance, reliable and power electronic circuits. So the main power electronics is the heart of the subject, which understand the function key and designing the robust efficient systems. Control rectifiers and inductive loads. As we know, the control rectifiers means which rectifies the signals or wavelengths, wave nature through the control rectifiers. And inductive loads means the lagging loads all come under the inductive loads. Generally, the rectifiers are used for AC signal supply to DC signal supply, alternating current to direct current. The rectifiers are used. As we know, the control rectifiers utilizes silicon control rectifiers SCR. In case why we use a silicon control rectifier mean the silicon is having less leakage current than germanium. So that's the reason, and it is more efficient than germanium. That's the reason we used control silicons in control rectifier, so-called thyristors. These regulate the output DC voltage unlike uncontrolled rectifiers, and turn on point of the SCR can be controlled, allowing the variable DC output. So the SCR can be controlled through turn on and turn off point characteristics, means the dynamic characteristics which can control the DC output. So the now as we know the SCR can control, it is like a switch which is uncontrolled rectifier, likely uncontrolled rectifier according to the variable output. So next one, inductive loads. Inductive loads such as motors, sinusoidals or transformers, energy and magnetic fields. When the current flow through the inductor in a sudden interrupted, the storage energy attempts dissipates, often leading very high induced voltages spike across the switching device, as we know accordingly. Now what is freewheeling diode? What it mean? What does it do? Freewheeling diode. Freewheeling diode alternative names are generally commutation diodes. Commutating means changing the AC to DC in case of a motor, or generally the commutation process of a diode or thyristor is used to switch off the switch, also known as the flyback diode. Commutating diode or clamp diode, its primary function is to provide a path for inductive current connection. It is specifically connected in a parallel with the inductive load, but with the polarity reversed relative to the main current flow from the rectifier. If we change the polarity, the reverse bias occur and the main current flow through the rectifier happens. Current path: when the SCR or other switching diodes turn off, the freewheeling diode becomes forward biased, providing an alternative path for the current to circulate through an inductor and the diode. So it tells about the current path. How does the current path in a forward bias conduction mode it happen? And next one, the working principle of control rectifier. SCR conduction, SCR turn off. Turn off is nothing but it is a dynamic characteristic, and diode activation. When the SCR is conducting, the current flows from the AC source through the rectifier and the SCR into the inductive load, the diode is reverse biased during this period. So if the reverse breakdown voltage happen, the diode may damage due to the reverse breakdown of voltage and flow the current, more current into it. For turning off the SCR and the diode natural commutation or gate signal is removed, the inductive load tries to maintain the current flow, causing the rapid voltage rise across its terminals. If the even though the inductive, it is an inductive load, if the gate signal is removed, the rapid flow of current happen and the voltage across the terminals may rise. Diode activation, this voltage reverse forwarded bias, the freewheel diode, which the conducts the storage energy in the inductor, is now dissipated through the diode, and the load is closed loop, preventing large voltage spikes across the SCR as we know it. And next one, before affecting before discussing on the load voltage and current effects, on the right side we can see the different types of waveforms in the picture. AC input voltage, Zener voltage, emitter voltage. It is a diode voltage. Triggering pulse, triggering pulse means main the voltage spike is given to trigger or to turn on the SCR. It is triggering voltage, and the load impact voltage and SCR voltage. uh, Eventually the change of AC input voltage signal, how it is changing, and what are the emitter voltages that trigger the pulse when it is given to the SCR. Now coming into the topic, effect of load voltage and current prevents negative voltage. What is negative voltage? When the polarities are reversed, the freewheeling diode clamps the load voltage approximately to zero during the period when the AC supply voltage goes negative, preventing the load voltage from becoming negative. It is clear. And maintenance of continuous current, it ensures that the load current remains continuous when even the input voltage across zero or becomes negative, by providing a path of stored inductive energy. What is the stored inductive energy? Half Li square, by providing the maintenance of continuous current. As we know, the inductor does not accept the sudden change in current even though the voltage is changed. Smooth current waveform, by allowing current to circulate, the diode significantly reduces discontinuous and ripples on the load current, resulting the smooth current waveform, beneficial for the inductive loads like motors. And impact of power factor and efficiency. The power factor means the cosine angle between the voltage and current is generally defined as the power factor. Cosine of phase angle, not the cosine angle. Cosine of phase angle between the voltage and current. Improved power factor. The freewheeling diode reduces the reactive power draw from the source by allowing the inductive energy and circulate locally, thereby significantly improving the output power factor and rectifier circuit. Enhanced efficiency, by enabling the stored inductive energy within the load itself rather than dissipating it, even where we overall the efficiency rectifier system of markable increased. When the storage, when the energy is stored in the inductive within the load itself, then there is no need of dissipating the rectifier system to enabling and efficient utilization of use or output power. Reduces harmonics. Smooth effect on the load current waveform contributes to a reduction of harmonic distortion in the input current, leading to a cleaner power draw from the source. So protection and reliability benefits. What are the protection and reliability benefits? Let us know about it. And device protection. The mid-gate voltage spikes. The mid-gate voltage spike means the efficient, the short period of time where the voltage spike to high level. The inductive current interrupted when an voltage spike that occurs in a high reverse efficient parameters, which can be caused immediate damage and a premature failure of switching components, ensuring thyristor blocking. And by reducing the reverse voltage stress, it helps to the thyristor for a regain and its forward blocking com- compatibility more quickly than the reliable after commutation, enhancing circuit stability and increased longevity. Overall, the protection offered by the diode contributes to the longer operational lifespan and improved reliability of the entire power electronic converter. So next one is principle and application and of circuit examples. The freewheeling diode is a variety of power electronic application in a single phase half control rectifier. The commonly used resistive inductive loads where the ensures the continuous current flow, and the DC motor drives handling high inductive nature and motor windings ensure smooth operation and following power supplies. The DC power supplies the main feedback of feeding the inductive loads and stability of efficiency. So these are all the practical applications and circuit examples. So advantages and disadvantages are ensures continuous load current and significantly improves the input power factor, and disadvantages are require the diode compatibility and Schottky types voltage rating, high increased power losses and diode forward voltage drop during conduction mode. So next one, summary and the conclusion. Final conclusion is about system reliability, enhanced performance and device protection, and current continuity. These factors are main summary of the present theory subject through ensuring the operations and improves power factor efficiency. The freewheeling diode is inspired component of calming the rectifier circuit, and with the interface inductive loads, the primary function is to provide path for the inductive current and stable high performance in the power electronic systems. Thank you.